All right, kids. Let's talk about what we're going to be doing today. So, last class we talked about displacement, we talked about velocity, we talked about acceleration, we talked about graphing. So if you don't remember any of that, just kind of maybe look at your notes real quick. But what I want to do today is introduce our next lab. Okay, so this is going to be a competition lab, and what you're going to be doing is all of the setup for it, and then the actual competition will be when I get back. So, but you need to do all this setup because the setup is just preparation to complete the lab. So if you don't get it done and do it well, when I come back, you're going to get last place. Well, some of you are going to get last place anyways, but yeah, you know what I mean. All right, so here's what we're going to be doing. I think I talked about this last time, the movie The Hunt for October, right? Nobody's seen it. Nobody has seen or know who Sean Connery is. All right, so I digress. This movie is about a submarine, and in particular, we're going to be watching a part here where the submarine is going through these underwater canyons. Okay, so they have a map. You'll see this in the video. You'll watch a little clip of the video. So they have a map, and they're plotting their course through there. So from the map, what they're going to get is that variable of distance, and then they know how fast the sub is going. So what I want you to do is when you're watching, see how they know when they're going to turn. All right, what are they doing, and how do they know when they're going to turn? Okay, so I want you to listen for all the terminology that we already learned, and kind of just watch and just take in the movie. So what you're going to do right now is pause the movie and let the sub know when everybody's done and gets to this point. So it should be really quick. Just kind of a quick introduction to show the clip uh, on the video board of the Hunt for October. I think it's like a 12-minute clip. Okay, so pause and go watch the movie. All right. So you just watched the movie. You saw that they use a stopwatch to count down, and they were giving a countdown when to turn and stuff like that. So if you notice, they had a map with a lane. They were trying to stay in the lane. So what you're going to be doing is using these constant velocity carts. So the little buggies at the front of the room are going to be your submarine. Okay, so how this is going to work, I'm going to talk about the competition aspect. You are not doing this today, so don't. I'm just giving it so you can think about where you're getting to. Okay, so how this is going to work is you notice that there's tape on the floor. That is the underwater canyons. I have made a map of the underwater canyons for you. This is very important. Do not, when you're using the cars, put your car on in the course today. If you do, I'm going to tell the sub to take your name down because that is cheating. You cannot be around the tape. All right, you got to be away from the taped area when you're using your cars today because that is cheating. Okay. So, how this is going to work is we're going to do some experiments today to get information we need to get about the cars. On the day of the competition, one of your group members will be inside the classroom with me with the car. The remaining parts of your group are going to be out in the hallway with the map and list of instructions. Don't worry about the list of instructions. You're going to do that next class. I'll explain how to do that next class. So you're like, well, how are we going to get communication back and forth? I have walkie-talkies, and the people out in the hallway will have a walkie-talkie. I will have a walkie-talkie in the classroom. The people in the hallway will be giving me instructions on what to do, and you, the driver that's in the classroom with me, can only do what they say. And you're going to plot your course throughout there. You're giving instructions, and really how it goes is the group that gets the furthest wins. And if anybody gets through it, they'll get all the way through the course, they'll get bonus points. Okay. But don't worry. I just want you to visualize that, but don't worry about that at all today. Do not worry about that. Do not try to solve that problem. Okay. Today, we're only doing a couple things. All right. So What I want you to think about is this. I'm going to pull up a little whiteboard here. Okay. So if we need to plot our course through this map, there's a couple things we need to know. Okay. So the first thing, which is kind of common sense, is in the video, they knew how fast the submarine was going. So this is your first problem here. So where's my mouse? Okay, sorry. I'm trying to use this first time I'm using this trackpad here. All right, one, we need to know, we need to calculate. Oh, this is not good. Hold on a second. This is not, I'm not like writing on the screen. There's like a pad right here. It's actually trash. This is not good. All right. Okay. Cars velocity. So that's your first problem. So let's kind of talk about that first. So the first part of the experiment is you need to calculate your car's velocity. Well, right now, we know it's moving at a constant velocity. That's the only thing we've talked about so far. So what we need to do is we need to look at the equation we have for velocity. We only have one equation, and it's this. V equals delta x over t. Okay? So again, remember, I am trying to solve for this. Dude, this sucks. All right, there we go. So it should be obvious that I need to do something that includes these two variables. Okay. So let's think about this. I need a displacement. I need a time. Probably easier to set the displacement. So in other words, when I make my data table, I'm going to set a column that's delta x. And what you're going to do is measure a distance. You're going to set a distance and then use your stopwatch to time it. And that will give us the two variables here. So let's give, again, you're always going to be trying to minimize error. So let's do a bunch of trials. So let's set two different distances. You're going to measure out 1 meter and then meter. Let me put a meter there. And then 2 meters, because that gives you two different distances. And what you're going to do is you want to time it multiple times, right? Because we want multiple trials. So what we can do is we can go T. Oh my gosh, dude, stop. All right. T1, T2, T3. So we've done 3 trials. And then what we're going to do is average it, average time. So you're going to have 3 times for each distance and then an average time. So therefore, we have a delta x, and then what we do is take our average time. So the last column in this chart should be my velocity. And all you're going to do is plug that information. All of that information goes back into this, and you should get it. And your velocity should be in meters per second, because your time's in seconds and your displacement is in meters. Okay. So you're going to do that first. Okay. Next, let's see if I can scroll down and figure this out here. Okay. If I hold this, there we go. Okay. Whoa. Come back. All right. Right there. Problem number 2 is, if you notice, whenever you're going to use these cars, right? If you're using these cars, you notice that they kind of veer off left and right. And if you notice, if you just look at the track is about 1 block wide, right? If I look at it, the width here is about the width of 1 block. This is the only time you want to think about blocks, okay? Everything else is in meters. So what I want you to do is, problem number 2 is, you need a max safe distance for your car. And what I mean by that is, on the day of the competition, if your car hits the side, you're dead. Like, that's crashing, right? So if we know that our car veers to the right or veers to the left, right? We might not be able to go the entire straightaway. But what we can do is figure out a distance that we know for sure. So what you're going to do is first drop the car and see if it goes left or right, right? If it goes left or right, then what you're allowed to do is you're allowed to set it anywhere in this thing. So if it veers to the right, I might set it on the left side so it has time to veer over, right? Instead of setting it here where it would veer over really quickly. Okay. So how do I erase here? Let me see. Erase. Okay. So let me draw this again. Okay, let me draw this lane. So what you're going to do is get to a block, right? Designate a starting point. This is not on the track. I'm just showing the lines that it's the width of the block. So if my car goes to the right, I'm going to drop it. I'm going to start it on this side, right? I'm going to start it here. And what I want to do is you're not timing this, you're just getting a distance. See where your car goes out. Maybe it goes all the way down here and crosses over. Then next time you do it, you start it here and it goes a little bit further that time and crosses over. And then this time it goes and it crosses over right here, right? So what you're saying is, let's say that this is 3.1 meters, this is 3.2 and 3.3 meters. Okay. So I just measured where it went out from this starting point. So from the starting point, it went 3.1 meters before it crossed the line, the horizontal line, okay, of a block. So what you want to do is, let's say I might set my safety. You can set this to be whatever you want. This is just per your group, right? So if I look at this, right, I might say, hey, let's set my safe distance to 2.5 meters. Because you know for sure every time you've set it down, it's gone past 2.5. Because your goal is to be safe. Because if you set it at 3 meters and you set it down and you drop it bad or whatever, you have a bad start where it kind of veers more to the right and you hit because you don't plan for it, right? Then you're dead. Your car crashes. So because I know, okay, my shortest one was 3.1, so I know for a fact 2.5 should be safe. So what you need is, okay, our max safe distance that we're willing to go straight is 2.5 meters. Okay. So those are the two things that you need to get done. It is very important that you get very accurate measurements and calculations here, because if you don't, no matter how good your map reading is, you'll crash because you have wrong numbers. Okay. So again, let me scroll up here real quick and I'm going to cover some like need to know things. Here, whoa, where's it at? What just happened? All right, there we go. There we go. Sorry, I'm getting used to this pen. It's new, brand new. All right. So this is our first problem. Calculate the velocity. This is your data table you should be making right here. I made it for you this time because it's our first lab. All right. This will calculate your velocity. Your equation for velocity is right here. Once you're done with that, you're going to go down here and figure out the maximum safe distance your car can go without running into the side. All right. Now, some keys here. You want to minimize error. So what I recommend is whoever is going to be driving that day should be driving today. All right. Also, have your car on. I wish I brought a car, but we only had enough, so I couldn't bring an example car. So you don't want to have your car off and you try to hit the on button when they say, okay, so say we have a countdown, we're gonna say, okay, go on 3, 2, 1, go. So if I'm in there listening, I'm listening and I hear you tell me 3, 2, 1, go, but I have to hit the switch. Maybe I missed the switch and it's no good, right? Then all of a sudden the map's not lining up and you're gonna crash. So what I would do is I would keep the car on, right? And have it hold it by the sides and have it just hovering so slightly above the ground. That way, whenever you get the countdown, 3, 2, 1, go, you just set it and release it. And that way it's easier to control. That way you're minimizing the error in that start stop. Okay. The last thing is this. Let's say I set my meter to be here, right? Okay. We're going 1 meter. to measure velocity. This is 1 meter distance, right? Do I want when do I start the stopwatch? When the front of the car is there, when the middle of the car is there, or when the back of the car is there? And then when do I stop it? Do I stop it when the front of the car is there? Do I stop it when the middle of the car is there? Or do I stop it when the back of the car is there? Okay. So the key here is this. It has to travel a meter. So as long as you match it up front to front, that car is going to travel a meter. I think front to front's easiest because you can see when it crosses this line, right? Middle is very tough because it's arbitrary. You got to figure out where the middle is. And rear is okay. It kind of matches too, but I think the front makes the most sense because you can see when it's just about to, and you can anticipate and stop the timer. So for this one, let's go put the front of the car at the start of 1 meter. It's going to travel 1 meter. So then you're going to stop the stopwatch when the car gets to the front of the 1 meter, front of the end of the 1 meter. Okay. So the two things you need to get done today is this. You need to have a velocity for your car and a maximum safe distance. If you do not have these things, you will be behind for tomorrow when I walk you through how to do the map. Okay. Do not mess around with these cars. All right. If you break them, you're going to come in last place. That's your only car. Also, make sure you write down the number of car that you have because each car is different. It's going to be a different velocity and it's going to be a different safe distance, right? So make sure you write down what car you have. There are little numbers on the back of them. Okay. Again, this is set up for your competition. So do a good job. That's all I got for you. So let's get out of here.